Hey everyone, welcome back. Ready for another deep dive?
Always.
Awesome. So today we're looking at something pretty interesting.
Oh,
Yeah, it's it's all about how to teach physics, but
that
like in a way that's actually engaging.
I'm intrigued. I mean, physics can be a tough subject to make, well, fun.
Exactly,
Yeah.
and that's what's so cool about what we're looking at today.
Okay, I'm all ears.
So get this: we've got these materials from a teacher workshop in Singapore,
Okay.
and their whole goal was to figure out how to make physics more hands-on and relatable, for students.
Using what, like lab experiments?
Well, sort of. They were really focused on using technology, specifically these things called open educational resources.
Ah, open educational resources. I'm familiar with those, but I'm curious to see how they applied them to physics.
Yeah, me too.
Yeah.
So materials we're looking at are from 2017, and they were all about using what they called ICT.
ICT.
Yeah, it stands for Information and Communication Technology.
Got it.
And they use it to teach things like kinematics, dynamics, and energy.
Okay, so the building blocks of physics. But how did they actually use ICT to make these concepts more exciting?
Well, that's where it gets really interesting.
Okay, I'm hooked. Tell me more.
So one of the main tools they used was this software called Tracker.
Tracker, what's that?
So it's this video analysis software, and basically you can use it to like track the movement of objects in videos.
Okay, I'm starting to see the potential here. So instead of just talking about velocity and acceleration, students can actually see it happening.
Exactly. So imagine like you're watching a video of a basketball being thrown through a hoop,
Classic physics example.
right? But with Tracker, you can actually see the ball's position, speed, and acceleration as it moves through the air.
Wow, that's a whole new level of visualization. Do you think that kind of hands-on approach really makes a difference in how students learn?
Well, from what I've read, it seems like it does. There's actually research suggesting that, when we physically interact with concepts, even virtually, it helps us understand them better.
Interesting. So they're not just seeing the formulas, they're experiencing the concepts in action.
Exactly. And the workshop didn't just assume that all the teachers would know how to use Tracker.
Yeah, that's a good point.
Right. So
Yeah.
they actually provided really detailed instructions, like step-by-step guides with screenshots and everything.
That's smart. Even experienced teachers might need a little guidance when it comes to new software.
For sure. But, it wasn't just about the technology itself. It was about using it in a way that really transformed the learning experience.
Right. The technology is just a tool. It's the pedagogy, the approach to teaching that really matters.
Exactly. And the workshop leaders had some really insightful ideas about why students often struggle with physics.
Like what?
Well, for one thing, they pointed out that a lot of students see physics topics as like separate, disconnected ideas.
I can see that. It's easy to get bogged down in formulas and forget about the bigger picture.
Yeah. And instead of seeing how physics applies to the real world, students often just focus on, passing exams.
So they're missing out on the wonder and relevance of it all.
Right. And the workshop materials even said something about students seeing physics as a collection of facts from, like, dead physicists.
Ouch. I mean, I get it. It can feel that way if you're just memorizing formulas and the definitions.
Yeah. So the workshop was really trying to change that perception. They wanted to make physics feel more alive
Yeah.
and connected to students' everyday experiences.
I like where this is going. So how did they actually do that? How did they bridge the gap between those abstract formulas and the real world?
Well, that's a great question, and we'll dive into that in the next part of our deep dive.
Sounds good. I'm ready when you are. So where were we? Ah, yes, bridging the gap between abstract physics and the real world.
Right. And they use Tracker to do that, remember?
Yeah, that video analysis software, that's a pretty clever way to make things more concrete.
I know, right? So in the workshop, they actually went into a lot of detail about, like, how to use Tracker effectively.
Makes sense. You can't just throw a new piece of software at teachers and expect them to figure it all out on their own.
Exactly. So they provided these, like, super detailed instructions.
Oh, like a user manual?
Kind of, but even better. They had step-by-step guides, screenshots, the whole 9 yards.
Wow, that's impressive. They
Yeah.
really thought of everything.
They did, and they didn't just focus on the technical stuff either. They made sure to connect it back to, the pedagogy.
The how and why of teaching, right? Not just the...
That's it. Like, they explain not just what to click, but why you're clicking it.
Yeah, I get that. It's one thing to know how to use a tool, but it's another thing entirely to understand the purpose behind it.
Totally. So, for example, they talked about things like calibrating the length scale in Tracker.
Calibrating the length scale. Why is that important?
Well, it's all about making sure your measurements are accurate. Like if you're tracking the movement of a ball, you need to tell Tracker how big the ball actually is in real life.
Yeah. Ah, so you're basically setting a reference point so the software can accurately calculate distances and speeds.
Exactly. And they explained all of that, like why it matters and how to do it properly.
That's really thorough. I can see how that would help teachers feel more confident using Tracker in their classrooms.
Yeah, for sure. But it wasn't just about like knowing how to use the software. It was about using it to get students thinking critically about physics.
Okay, so less rote memorization, more deep thinking. I like it.
Yeah. So like one of the things they emphasized was getting students to ask their own questions about the videos they were analyzing.
That's a good strategy. It encourages them to be more active learners.
Exactly. So instead of just passively watching a video, they're actually engaging with it, trying to figure things out.
Makes sense. Do they give any examples of the types of questions they were hoping students would ask?
Oh, yeah, for sure. Like, let's say they were watching a video of a ball being dropped.
Okay.
Yeah.
Classic physics scenario.
Right. So they might encourage students to ask things like, does a heavier ball fall faster than lighter one?
Interesting. Or maybe, how does the height from which the ball is dropped affect how long it takes to hit the ground?
Exactly. And those kinds of questions can lead to some pretty cool investigations.
I bet. But how do they go from asking those questions to actually understanding the physics behind what they're observing?
Well, that's where the next step comes in, using models.
Models, like
Yeah.
mathematical models.
Yeah. So the workshop encouraged teachers to help students connect what they were seeing in the videos to, those more abstract physics concepts.
Okay, I'm with you. So they're not just observing, they're trying to make sense of what they're seeing through the lens of physics.
Exactly. Like they might ask students, how is the ball's speed changing as it falls? Or what does the slope of this graph tell us about its acceleration?
Ah, so they're learning to interpret those visual cues and translate them into the language of physics.
You got it. And all this leads to the really fun part, carrying out the investigation.
The investigation, huh? Sounds exciting. Tell me more.
So this is where students actually get to use Tracker to like collect and analyze data.
Okay, so they're becoming mini scientists. That's awesome.
It is, and the workshop materials provided very specific instructions on how to do this, like how to track the motion of the ball, how to collect data points, and how to use those data points to draw conclusions.
Wow, sounds like they really covered all the bases.
They did, but they also emphasized that it's not just about crunching numbers. It's about thinking critically about what that data means.
Right. Data without interpretation is just noise.
I like that. Data without interpretation is just noise. It's so true.
So they're encouraging students to go beyond just collecting data, to actually think about how it supports or refutes their initial hypotheses.
Exactly. They're using evidence to build their understanding.
This is awesome. It sounds like they're giving students the tools to think like real physicists.
They are. And to really bring it all together, they introduce this thing called a performance task.
Okay, a performance task. What's that?
Well, it's basically like a mini project.
Yeah.
A chance for students to apply what they've learned.
I see. So it's not just about understanding concepts in isolation. It's about putting them into practice.
Yeah, exactly. So, for example, one of the performance tasks they suggested was having students predict how long it would take for an object to fall from a certain height.
Like dropping a watermelon from the roof of the school.
Well, maybe not a watermelon, but you get the idea. And they even suggested having students measure the height of their own school building.
Whoa, that's taking it to the next level. So they're not just working with hypothetical numbers, they're actually dealing with real-world measurements.
Exactly. And then they could use Tracker to analyze a video of an object being dropped from that height and see how their predictions match up with reality.
That's so cool. I can see how that would make physics feel way more relevant and engaging for students.
Me too. And they didn't stop there. They also suggested using those open source physics simulations we talked about earlier.
Oh yeah, the simulations. I'd almost forgotten about those.
I know, right? There's so much packed into this workshop.
So how did they use the simulations in the performance task?
Well, like imagine you're limited by the height of your school building for the real world experiment. Right?
Yeah, you can only go so high.
Right. But with the simulation, you could explore what happens if an object falls from like 100 meters or even 1,000 meters.
Whoa, that opens up a whole new world of possibility.
It does. And you could even change other variables in the simulation, like the gravitational constant or introduce air resistance.
That's a great point. So it allows them to isolate different variables and see how they affect the outcome, something that would be really hard to do in a real-world experiment.
Totally. It's all about giving students more control over the experiment and allowing them to explore those what-is questions.
I'm loving this. This workshop seems like a fantastic blend of hands-on activities, technology integration, and real-world applications.
I know, right?
Oh.
It's like they took everything that's cool about physics and packed it into one awesome learning experience.
But let's be real, that are always challenges when it comes to incorporating new stuff into the classroom, right?
Well, absolutely. And the workshop organizers were definitely aware of that.
So how did they address those challenges?
Well, that's a great question, and one we'll definitely explore in the next part of our deep dive.
Okay, I'm on the edge of my seat. Let's get to it.
All right, so we've seen how awesome this workshop is.
It is pretty impressive, right?
But, there's always that question.
Right.
Well, how do teachers actually make this work in their classrooms?
Right, with all the, the real-world constraints and stuff.
Exactly. Like, remember how we talked about access to technology being a big issue?
Yeah, not every school have, like, a ton of laptops just lying around.
Exactly. And the workshop organizers were definitely aware of that.
So what do they suggest? Like, how do you teach with these cool tools if you don't have the resources?
Well, they really encourage teachers to be, creative.
Create.
Like, think outside the box. They suggested things like pairing students up to share laptops.
Oh, that's smart.
Right. Or, like, having backup plans, in case the internet goes down.
Oh, like printed versions of the simulations.
Exactly. It's all about being flexible and adaptable.
I like that. It's a good reminder that good teaching isn't about having all the fancy gadgets. It's about being resourceful and, well, good at teaching.
Totally. And they were also realistic about the time commitment.
Yeah, learning new software and redesigning lesson plans can take a ton of time.
It can. So they encourage teachers to start small, like pick one or two activities that they really liked and focus on mastering those first.
That's a good approach. Don't try to do everything at once. Just focus on doing a few things really well.
Exactly. And then once you're comfortable, you can gradually expand from there.
So it's like a gradual process of, building confidence and expertise.
That's it. And they also provided ongoing support, which I thought was really cool.
Oh, yeah. What kind of support?
Well, remember that WhatsApp group we talked about?
The one for the teachers?
Yeah. It wasn't just for casual conversations. It was a place for teachers to connect with each other
Yeah.
and ask questions and share resources.
So like a community of practice. That's awesome.
It was. And they also gave teachers access to a ton of online resources like this thing called the Open Source Physics Digital Library.
Whoa! A whole digital library just for physics. What's in it?
It's basically this massive collection of simulations and applets and other interactive tools, all freely available.
Wow, that's amazing. I bet teachers love that.
Oh, they did. It was a huge hit. And it really aligns with, the whole spirit of open educational resources.
Making knowledge accessible to everyone. Right?
Exactly. And the workshop itself was a great example of that. They shared all of their materials openly so that other teachers could benefit from their work.
That's awesome. It's like they were paying it forward.
They were. And I think that's a really important takeaway from all of this. Like the power of collaboration and sharing in education. It's not about, hoarding your best ideas. It's about sharing them with others so we can all learn and grow together.
I totally agree. When teachers work together, everyone benefits, especially the students.
That's it. So I guess the big question is what would happen if we applied this approach to other subjects?
That's an interesting thought. Imagine if all subjects were taught with this kind of hands-on, inquiry-based approach.
I know, right? It's pretty mind-blowing.
It is. And, I think it's definitely possible. We have all the tools and resources we need. It's just a matter of, changing our mindset and embracing new ways of teaching and learning.
Well said. And I think this workshop has given us a lot to think about, in terms of how we can make education more engaging and relevant for all students.
I agree. It's been a fascinating deep dive.
It has. So thanks for joining us on this journey into the world of open source physics in Singapore.
It's been a pleasure.
And if you're a teacher or even just someone who's curious about physics education, we encourage you to check out the Open Source Physics Digital Library.
Yes, it's a treasure trove of resources.
And remember, the power to change the way we learn is in all of our hands. So keep exploring, keep questioning, and keep sharing your passion for knowledge.
Absolutely. Never stop learning.
That's a great way to put it.
Yeah.
Until next time, keep diving deep.